meteorologist and severe weather specialist, Dean D. Davison, the Weather Pros. We're going to go over how we can see tornadoes on radar. Pretty distinct couple ways of seeing tornadoes on radar. Doppler radar was created by Christian Doppler, and that's who is named after. The main reason is to see things going towards and things coming away from radar, which is the Doppler effect. And we can get on more of that basic meteorology. But we take a look at this image, which is a supercell thunderstorm, Hook Echo. This has a tornado on the ground. This is Tuscaloosa, Alabama in 2011. And you can see lots of rain and hail would be in this northwestern area. And then it comes down and in. Now this little thing here with the pink is called a hook. It's called debris ball. This is debris on the radar. Now, with some of the new dual polarization radar, you can go to the CC scan or the coefficient scan, where we can see stuff dropping away from the radar, which would come up as blue in the midst of pinks and reds, which would show us, well, there's debris in the air. But before that, we could see this debris ball, and then your major hail and would be up here, your rear float flight downdraft will be down here, and that was how we looked on our radar. And we can see in other ways. We have the first one, which is the classic Hook Echo. In the reflectivity, you can see this backwards. And you can see the C inflow winds will be coming into this and hooking around your basic hail and high winds would be out here. And then we would look on the velocity scan and see we have winds coming towards radar and winds going away. And in that circle where the winds, when they switch together and they get together, that is called a, what they call that? That is called your gate to gate. And on gate to gate, meaning green on red, strong rotation, pretty much shows you have a tornado. This is on your classic supercells. Now, in the eastern United States, we get a lot of linear thunderstorms, a lot of thunderstorms and lines. And there is tornadoes that form on them. These are mainly spin-ups. And EF0, EF1, EF2s, we don't really have seen too many QLCSs form long-term tornadoes that you see on the supercells, which get to EF5. But your QLCS, or quasi-linear convective system, which is a line of thunderstorms, and there's some rotations on that. This happens also with derechos, where you have the winds coming in, strong winds pushing out. You see the winds right here at the face of the storm, sometimes out miles ahead. You get a spin-up tornado, or sometimes a gustnado. They spin real fast, and that will cause these spin-up tornadoes. They're EF0s, usually the EF2s, and they are on a quasi-linear convective system. On a regular radar, you really can't tell what this is at. This is just a line of thunderstorms. You get the backwards. See here being strong winds are pushing up, but it's right along these edges, or in the, if there's a nice squall line, you'll see a comma head. That would be where you would look for the tornadoes. But mainly on the ratios and things of that matter, right along the leading edge and the gust front, get spin ups, and we get tornadoes that way. But that's how we tell the difference on radar. Like I said, these tornadoes, supercell tornadoes, this was an EF5. Okay, strong debris ball, very classic look. You can see on two different types: the velocity scan, which would be storm relative or base, and then QCLS, which we'd have just spin-ups along the edges. So, a little bit of information on how you look at tornadoes on radar. For more Weather 101, stay with the Weather Pros, liveweatherblogs.com. Thank you for watching. Stay safe out there.